All right, so we're going to graph parabolas now, and when we graph parabolas this time, we're going to do it using the 5 key points that we talked about in the last videos. And so to find those, we know how to find those now. So really, this is really just going to be summarizing all of those points and putting them actually on the graph. So the only one that we didn't talk about is this last one down here, which is the point symmetrical to the y-axis. So if I said the point symmetrical to the y-intercept, what I mean is a point symmetrical is the same distance but on the other side of the axis of symmetry. So we're going to also be doing that axis of symmetry line as well. Right? So here's an example of graphing using the 5 key points that we know how to calculate now. Right? So we're going to start off and we're going to calculate the vertex, which, just to remind you, to calculate the vertex we're going to use negative b over 2a. Right? And we're going to plug in our values. So I'd say up here, this is my b value, and here my a value in this case is the one that's hiding next to x squared. Right? So if I ask you to calculate the vertex, we're going to say start off with negative b over 2a, which is going to be a 6 in the b spot, so negative 6 over 2 times 1. And that looks like negative 6 over 2 is going to be negative 3. So I'm going to say for my vertex point, which I'm going to put over to the side here, I'm going to say there's definitely a negative 3 in the x spot. Okay, so before I go any further, I want to remind you that the axis of symmetry is going to be important here. And when we want to calculate that, we want to put that on our graph, and we've already calculated it. It's the negative 3 value here. So I'm going to take this negative 3. I'm going to draw myself a vertical line right here. Here's negative 3. So I'm going to start at the top from negative 3. And I'm going to draw myself a line. And I'm going to say there's a dotted line that travels right down negative 3. Okay? Half of the parabola is going to be over here, and the other half is going to be on the other side of this axis. And we also know that the vertex is going to be right on that line. So we want to have that picture drawn. So once you calculate your x part of the vertex, that's also going to be that important dotted line, and you want to put that on your graph. All right, so now that we have that, let's calculate y. And to do that, I'm going to take my x value and plug it in. I'm going to use this formula, and I'm going to say, well, y is equal to, and instead of x squared, I'm going to say negative 3 in parentheses squared. Make sure that's in parentheses before you square it. Okay, plus 6 times negative 3 plus 8. Okay, so if I simplify this, this looks like a 9 minus 18 plus 8. Well, 9 minus 18, well, that's negative 9. Negative 9 plus 8 is equal to negative 1. So in this case, my y is equal to negative 1. And that's my vertex. So I can go over to my graph now and say there's a point negative 3, negative 1 right here, and that's my graph. Okay. I also know that my graph's going to go up, and it's going to be a regular U shape like this, and I know that because my a value is a positive number, and I always get a regular U shape with a minimum. So I can kind of start to see what my graph's going to look like. Okay. So let's calculate the 2 x-intercepts. We have 1 point. I need 4 more. Right, so my x-intercept is going to be, let's put a 0 in the y spot, and I'm going to say x squared plus 6x plus 8. I now have to factor and solve and see if I can find those x-intercepts using that. Well, it looks like I can. I can say this is the same as 2 times 4. This is the same as 2 plus 4. So this becomes x plus 4 and x plus 2. And if I set each of these equal to 0, I get x plus 4 is equal to 0. And x plus 2 is equal to 0, and I get 2 x-intercepts. When I subtract 4 on both sides here, I get x is equal to negative 4, so I'm going to get this x-intercept. And I can do the same thing. I can say when I subtract 2 and subtract 2, I get negative 2 as an x-intercept as well. And so I'm going to put those points on. And if you notice, negative 2, 0 and negative 4, 0 are exactly 1 unit away. So I'm keeping that symmetry that we talked about. We said half of the points are going to be on the right and half on the left. And that actually happens with my x-intercepts. One's 1 unit to the right, the other is 1 unit to the left, and that's good. That means that I'm on the right track. Okay. My y-intercept is nice, right? I'm asking you to plot the y-intercept. If I plug in a 0 here and a 0 here to get rid of these and find out what y is, it actually comes out to just be that c value. So this c value, 8, so if I count on my y-axis, go up to 8, 1, 2, 3, 4, 5, 6, 7, 8, it's right here. Okay, that's my y-intercept. Okay, and if you notice, I have now 1, 2, 3, 4 points. I need 5. The 5th one is that one that we haven't talked about, which is the reflection over the axis of symmetry, the point symmetric to the y-axis. So if I count and I say this point here, the y-intercept is 1, 2, 3 units until I hit the axis, that means that there's another point 3 units on the other side, which is going to be right here. So if you notice, I have my nice parabola shape. This gives me a nice U shape, right? This is a good looking graph, and I know because all quadratics should look like a U shape, right? So it looks like I get a U right there. There's one half, and I get the other one right on the other side. It's going to look something like that. Okay, so I have my parabola shape using the 5 key points. Okay, so that's going to be the basic idea for all of these problems. And in the next video, what we're going to look at is just some different cases for x-intercept. Sometimes, as we saw when we did solving, sometimes it's not really this easy. We're going to have to do a little bit more work. So I'm just going to show you a couple more examples of what the x-intercept calculation might look like for those problems.